All right, so number one is a multiplication of rational expressions. We need to factor anywhere that's possible first. And so we're going to factor the bottom left numerator is a trinomial. So we're going to factor with the cross method what multiplies to AC and adds to B. A is 1, C is 12, so AC is 12, B is -7, and the two numbers that work there are -4 and -3. And remember when the AC value, when the A value is 1, you can do the shortcut method of factoring, meaning you do not have to do grouping next. You can just use x minus 4 and x minus 3 for your factors. This is the bottom left. And for 6x squared, I'm going to factor 6 as 2 times 3, and the x squared as x times x. And then for the upper left, the numerator on the left, it's just 2 times x. You can't factor that down anymore. And then x squared minus 9 is difference of two squares, right? Because we're subtracting two things that are perfect squares. And so we square root each one. That gives me x and 3. And I make a minus version. And now I cancel anything that occurs on the top and bottom. That's the same. So for example, there's x minus 3, x minus 3. Remember, basically it's just something divided by itself, which gives us 1. But we don't write the 1 because when you multiply it by everything else, it doesn't change anything. So we just say we cancel it. I also see a 2 on top and a 2 on bottom. And I see 1x on top to match with 1x on the bottom there. And that's all I see. So what we have left over is our final answer. On top, what we have left is x plus 3. And on the bottom, we have x minus 4 and a 3 times x. All right, and let me just show you one real quick bad math alert. The x on top cannot be canceled with any of the x's on the bottom, because the x on top is being added to the 3. You can only cancel things that are being multiplied. Same thing, we can't cancel the 3 on top with the 3 on bottom. But look at the difference. The 3 on bottom is being multiplied by everything around it. So you could cancel it if there was another 3 on top being multiplied by something. But the 3 on top is being added, so we can't use it for canceling. All right, for number 2, we have a multiplication, again, of rational expressions. But what's different here is the grouping on the upper left numerator. So let's start out by multiplying across the top and bottom. Notice how I put parentheses around the w minus 8 as I combine these two expressions and the w minus 3 on the bottom, because those are groups. And so we need the parentheses when we go to multiply them by other stuff. And the only thing that can cancel here is there's a w minus 3 grouping. So on top we have 2 w minus 3s, and on bottom we have 1. So remember, we say that wherever the bigger exponent is, that's where the factor is going to stay. So I'm going to keep a w minus 3 on top and subtract the powers. Remember, the w minus 3 on the bottom has a 1. So I take the 2 here minus the 1 here. That gives me 1. And so my power for my answer is w minus 3 to the 1. Also remember, we don't have to write the 1. So I'm going to actually erase it. And then I have w minus 8 on top and an 8w still on the bottom. So basically we canceled out 1w minus 3 on the top and bottom, which left us 1 remaining on top. And the 8s do not cancel for the same reason that I talked about in number 1. because the 8 on top is being subtracted, not multiplied. So it's not a factor that we can cancel. Okay, number 3 is dividing rational expressions. Remember, we want to multiply by the reciprocal, so we keep the first one the same, change the division to multiplication, and flip the second fraction. So this becomes x squared plus 12x plus 35 over x plus 5 times x plus 3 over x squared plus 10x plus 21. So we factor anywhere that we can, and here are the places we can't. We can factor here and here, but x plus 3 and x plus 5 don't factor anymore. So these are trinomials, so we're going to do the cross method. Multiplies to AC and adds to B. So in the top left numerator, A is 1, C is 35, so A times C is 35. B is 12. So it multiplies to 35 and adds to 12, 7 and 5. And because the A value is 1, we can do the shortcut method where we do not have to do grouping. So I just say this is x plus 7 times x plus 5. And then there's the x plus 5 on the bottom. And in the second fraction, the x plus 3 on top cannot be factored, so I'm just going to write it down. Now notice how there's no dot for multiplication in my numerator. That's because I'm going to go ahead and just multiply across the top and bottom while I'm also factoring at the same time. So I went ahead and I did the smushing. That's part of the multiplication. So then factoring x squared plus 10x plus 21 multiplies to AC and adds to B. Again, here A is 1, C is 21, so 1 times 21 is 21, and then B is 10, and 3 and 7 multiply to 21 and add to 10. And again, because the A value is 1, I don't have to do the long method where I group next. I can just go straight to x plus 3 times x plus 7. And now I look for common factors in the top and bottom, in the numerator and the denominator. I see x plus 7s, so I can cancel those. I see x plus 5s, so I can cancel those. And I see x plus 3s. Now, everything cancels out, so you might feel like the answer is 0, but that is wrong, okay? So we don't actually have nothing left. We have 1 left, because when you divide the x plus 7 divided by x plus 7, really that's something divided by itself, so that's 1. And the x plus 5 divided by x plus 5 is also 1. And x plus 3 divided by x plus 3 is 1. And we're multiplying all those 1s together. So 1 times 1 times 1 is 1. For number 4, we are dividing by simplifying terms. So we have 2 things going on here. We have the 15 over the 25, and then a over a squared. And we simplify them individually. So 15 over 25, we want to divide out whatever they have in common, the biggest thing that they have in common. And this is 5 here. So that leaves me 3/5. And then for the a's, you want to keep your base on whichever side of the fraction has the most a's, which is the bottom. And then you subtract the exponents, right? The a on top really has a 1. 2 minus 1 is 1. So it's 3/5 a to the first on the bottom, but we don't have to write that 1 exponent. So I'm just going to write 3 over 5a. For number 5, again, we want to simplify. This requires factoring first. And there's 2 different factoring methods going on here. On the top, it's the cross method, and we know that because there's a trinomial. And on the bottom is difference of two squares, because I'm subtracting two perfect squares. So let's start with the numerator and do the cross method. We want to know what multiplies to AC and adds to B. A is 3, C is -5, so multiplying those gives me -15, and B is -2. So the two numbers that are going to work here are -5 and +3. Now, since the A value is not 1, we have to do the long method, not the short method. The long method is where we do grouping. So remember, this -5 and this 3 we got. We're going to use those to rewrite the middle term, the -2m, like this. -5m and +3m. Right? That still equals -2m. We're just rewriting it using those two numbers we just found. And then the 3m squared from the beginning stays the same. And the -5 from the end stays the same. And now that we have 4 terms, we're going to do group. So the GCF in the first group is just an m. So after I divide that out, I'm left with 3m minus 5. And the GCF in the second group, there is no GCF. So when that happens, we make it 1. That's going to be a placeholder for us. So then it's plus 1 times 3m minus 5. And now we take the GCF of both of those groups together. They have 3m minus 5 in common. And what they have left over is m plus 1. So that's my numerator now, factored. 3m minus 5 times m plus 1. And then on the bottom, the difference of two squares, you square root both terms. That gives you m and 1. And you make a minus version and a plus version. And now that we're completely factored, we look to see what's the same on top and bottom. And that's m plus 1. So I'm going to remove those. And that leaves me 3m minus 5 over m minus 1. All right, so let's go to the back, or the second page. Now we're going to practice with adding and subtracting. When you do these problems, so for number 6, these fractions have the same denominator. And when you're adding fractions with like denominators, you keep the denominator the same. And now we add across the top, n squared plus 6n. And then you factor to see if you can cancel anything. Both of these use the GCF method of factoring, the greatest common factor. The numerator has a GCF of n, which leaves n plus 6 left over. And then the bottom has 5 in the denominator, so that's 5 times n plus 6. And the n plus 6's cancel, leaving me n over 5. And in number 7, we start the same way because we notice that the denominators are the same. So we write one fraction with that denominator without changing it at all. And then we add or subtract across the top. So we have there are no like terms, so we leave everything separate. 2t squared plus 5t minus 12. Now, because both the top and the bottom are trinomials, we are going to have to do the cross method on both of these, but they're going to work a little bit different. So in the denominator, the A value is 1. So we can do the short AC method. In top, the A value is not 1. So we have to do the long AC method. So the numerator is going to be long AC, and the bottom is going to be short AC. So let's start with the bottom. What multiplies to AC? AC is 1 times 16 and adds to B, which is 8, is 4 and 4. So the denominator factors into T plus 4, T plus 4. And in the numerator, AC is 2 times negative 12, so that's negative 20. B is 5. So the two numbers that multiply to negative 24 and add to 5 are 8 and negative 3. But now we're going to do our long AC method, right? Because the A value was not 1. So we'll use the 8 and negative 3 to rewrite 5t. So that becomes 8t. Oh, look what I did wrong. The 5 is negative, so I should have made the 8 negative and the 3 positive. So rewriting negative 5, oh no, it is a plus. It looks negative because of the way I circled. Go back. 8 is, okay, hold on. I'm sorry, you guys. Good thing I had a little tiny eraser. So 8's positive, 3's negative, because this is really a plus right here. Okay, I'm back. So 8t minus 3t, I've rewritten the middle term. And the other two terms stay the same. So that's a minus 12 on the end and a 2t squared on the front. And then I do grouping. Group the first two and the second two. Divided GCF out of the first group. The 2 and the 8 have a 2 in common. And they each have a t in common. So that gives me 2t times t plus. And then in the second group, they have a 3 in common. And anytime the first term is negative, you want to include the negative in your GCF. So that gives me minus 3, parentheses, t plus 4. Now they have a t plus 4 in common. And what they have left is 2t minus 3. That's going to go in my numerator. So t plus 4 times 2t minus 3. You too, Rolanda. Thank you. That's okay. And then the t plus 4's cancel, leaving me 2t minus 3 over t plus 4. All right, and number 8 down here, we have a complex fraction. Remember, that means a fraction of fractions. And the first step that we talked about last week was to rewrite this going from left to right. Right now it's written top to bottom. So rewriting left to right gives me 9x squared over x squared plus 11x plus 30 divided by 3x squared over x squared minus 36. That's a division of two rational expressions. So we talked earlier about how that's a multiply by the reciprocal. You're going to keep the first one the same. Change division to multiplication and flip the second fraction. And now you factor everywhere that you can. I'm going to factor and smush it all on top and smush it all on bottom. I'm going to do that all in one step. And by smush the top and bottom, I mean multiply across the top and bottom. So for 9x squared, I'm going to factor as 3 times x times x. And then for the bottom, that's a trinomial. There's 3 terms. The a value is 1. So I'm going to do the short AC method. A times c is 30. B is 11. 5 and 6 are what will multiply to 30 and add to 11. And I do not have to do grouping because the a value is 1. So that's, I can go straight to my factored form, x plus 5 and x plus 6. And then next, I'm going to factor the numerator here on the right numerator. That's 2 perfect squares being subtracted. So that's difference of 2 squares. We square root them, and we make a minus version and a plus version. So x minus 6, x plus 6. And then the denominator on the right, 3 times x times x. And now we just cancel everything that's the same on top. I see a pair of 3's. 2 x's can cancel with each other. And then there's x plus 6, x plus 6. So that leaves me 3 times x minus 6 on top and x plus 5 on the bottom. And then for this last problem, it says write a simplified expression for the area of the following rectangle. Well, here's what you have to remember first of all, is that area equals length times width. And I'm given a length and a width, so I just have to multiply them, right, to find the area. So I just set this up where I'm multiplying those two things, the length times the width. So we'll call this one the length, 36 minus x squared over 4x plus 6 times 10x cubed plus 15x squared over 5x cubed minus 30x squared. All right, so now I just get to factoring. And I'm going to factor in mush at the same time. So the upper left numerator is 2 perfect squares being subtracted. So I'm going to do difference of 2 squares there. That gives me 6 and x, and I'm going to make a negative version and a positive. And the 4x plus 6 on the bottom of that has a GCF of 2. So I factor that out and get 2 times x plus 3. And now I'm going to the numerator on the right equation. Okay, the top part of the second fraction. Sorry, I'm not using my words correctly. Let me just highlight it. I'm here. There we go. So that is a GCF because there's only 2 terms. The 10 and the 15 have a 5 in common. And x cubed and x squared have x squared in common. And then what's left over in the first term after I divide that out is just 2x. And in the second term is just 3. And then in the denominator there, 5x cubed minus 30x squared, the 5 and the 30 have a 5 in common. X cubed and x squared again have x squared in common. And when you divide 5x squared out of the first term, you get x. And when you divide it out of the second term, you get minus 6. So what we have in common in the top and bottom here is 5x squared can all go at one time, 2x plus 3. And the way it looks right now, nothing else matches, but I'm going to show you a little algebra trick for making x minus 6 and 6 minus x match. If you take the 6 minus x on top and divide out a -1. Okay, so think about you have this. Think about taking a GCF out, okay? If you take a -1 out, that leaves you now -6 plus x inside the parentheses. And inside the parentheses, you can reverse the order and write it as x minus 6. Remember, the order I take to work doesn't matter. My commute doesn't matter. The commutative property says you can switch for addition and subtraction, and it'll give you the same answer. So now let's rewrite this as, instead of 6 minus x, -1 times x minus 6. And then we still have the 6 plus x on top. Or we can even rewrite that now if we wanted the x first. Over 2 times x minus 6. And now we can cancel out one more thing that we wouldn't have been able to cancel out if we didn't divide out the -1. So -1 times x plus 6 over 2, or you could even not write the -1. You could just write negative. That's an option. There's options. There you go.